Hey, it's Hannah. Hannah Baker.
Oops, wrong tape.
It's Kyla. Kyla Mercado. It's me, live and in stereo. So get a snack, settle in, because I'm about to tell you the concept of thermodynamics. Yes, you heard it right. Thermodynamics. Thermodynamics is like a game that helps us understand how heat and energy work. So imagine you have a hot bowl of soup and a cold glass of water. If you leave them on a table, what happens? Have you ever noticed that the soup cools down over time and the water starts to warm up? That's because heat likes to move around and make things balance out. The cooling down of the hot bowl of soup is an example of an exothermic process. Exothermic process, or reactions, release heat energy into the surroundings. In this case, the hot soup gradually transfers heat to the surrounding environment, causing its temperature to decrease over time. Whereas the warming up of the cold glass of water is an example of an endothermic process. Endothermic reactions absorb heat energy from the surroundings. In this case, the cold water absorbs heat from the surrounding environment, causing its temperature to increase over time. So to demonstrate the concept of thermodynamics, here is a simple experiment to be done at home. But I don't have a laboratory at home, have I? But we do have a kitchen. You see, cooking is like conducting a scientific experiment in the kitchen. When you cook, you're combining different ingredients, adjusting temperatures, and observing chemical reactions taking place. It's a fascinating blend of creativity and chemistry, where flavors and textures are transformed through various cooking techniques. Without even realizing it, you become a scientist exploring the principles of chemistry through the art of cooking. So get ready to discover how thermodynamics comes to life in your very own kitchen. So cooking involves various thermodynamic principles. And here is an experiment that demonstrates the concept of heat transfer and energy conservation in cooking. So your materials needed: two identical pots, water, stove, and a digital thermometer. So the procedure are: fill one pot with water and leave the other one empty. Next, place both pots on the stove, then turn on the heat to the same level for both burners. Measure and record the initial temperature of the water using the thermometer. Monitor the temperature of the water in the pot with the thermometer as it heats up. Observe the time taken for the water to reach a boiling point. Once the water in the pot boils, turn off the heat for both burners. Lastly, measure and record the final temperature of the water in the pot. So the explanation in this experiment is that the pot with water represents a system that undergoes heating, while the empty pot represents a system that does not receive direct heat. When heat is applied to the burner beneath the pot, the heat energy is transferred through conduction from the burner to the pot, and further to the water inside. This heat transfer causes the water temperature to rise gradually until it reaches its boiling point. On the other hand, the empty pot does not contain water to absorb the heat energy directly. Therefore, the temperature of the empty pot or pan does not rise significantly compared to the pot with water. Once the water in the pot reaches its boiling point, the heat is turned off for both burners. The pot with water will retain some of its heat, gradually losing it to the surroundings through conduction, convection, and radiation. By measuring the final temperature of the water in the pot, you can observe the cooling process and the conservation of energy. Through this experiment, you can understand how heat is transferred from a heat source to a substance, for instance, water, in cooking, the time required for heating, and the subsequent cooking process. It demonstrates the principles of heat transfer, energy conservation, and temperature changes involved in cooking and thermodynamics. To wrap up, thermodynamics is about how heat and energy behave, how they move, and how they affect the world around us. It's a science that helps us understand why things get hot or cold, how energy is transformed, and how we can make the most of it. So that's all for our kitchen lab experiment. But I have a question. If we'll be doing this experiment in an actual laboratory, what materials do we need? I think that's for you to find out. Thank you for tuning in, and I hope this experiment inspired you to explore further, because you know I do.